We are ready to start again with the last half of talks for this evening. And the first one on stage is Enrico Zimuel. Hi, Enrico.
Hi, Alessandro. How are you?
Fine, thanks. How are you?
Good, good.
Happy to have you here. Happy to see you again, even if not in person. Let's hope for next year. And for those who don't know Enrico, he's a long-time programmer in PHP since 1996. So I think that outdates a lot of us. And he's currently working as principal software engineer at Elastic, and is maintaining the PHP and Perl libraries for that database. And he's also a co-author of a trove of open source libraries, Apigility, Expressive, the Zen framework, now known as Laminas framework. He's a speaker in probably more than 100 conferences. He's author of a nice book in Italian, which is Sviluppare in PHP 7, which is obviously a nice starter for anyone that wants to start writing in our favorite language. And so much more, like he handles the PHP user group in Turin too. So if you're around there, they're organizing their first in-person meetup this month, right? If I'm not mistaken.
Yes, 23 of June.
Yeah, that's great. We are starting seeing.
That's a try.
That's the first try. Yeah, right. Let's start trying to see face-to-face again a little at a time. So you're here today to talk about Elasticsearch, well, programming PHP and Elasticsearch, right?
Yes, that's the title of my talk. I hope you will enjoy it.
Yeah, so the stage is yours, up to you.
Thank you, Ale. So, good morning, good afternoon, good evening to everyone. As Alessandro said, my name is Enrico Zimuel, and I'm a principal software engineer at Elastic. So today I would like to talk about Elasticsearch, a little introduction to Elasticsearch and how to use it in PHP, how to program Elasticsearch in PHP. So we'll see how to connect to Elasticsearch, how to provide a basic operation like index, bulk, and search, some advanced feature, because there are a lot of features in Elasticsearch. Of course, in this presentation, I'm not going to cover all the features, but I would like to give you some flavor of the main, feature, or the more interesting, I would say, that are fuzzy search, aggregation, or more recently, we added a new feature that is named Schema Read, starting from version 7.12 of Elasticsearch. So it's very interesting. I will try to give you a flavor. And I will also talk about the asynchronous communication that you can perform in the PHP client against Elasticsearch, and also the future works, because we are working on a new version of the client with some major news. So a very short introduction to Elasticsearch if you are not familiar with this software. So basically, Elasticsearch is a distributed, free, and open search and analytics engine for all types of data. So it's mainly used for search, activities, but not only, even for analytics. It's scaled by the design, basically, and you can manage any size of data. So this is very interesting because it's a tool that can grow according to your data. So if you are managing few megabytes or few gigabytes of data, that's fine. But if you want to perform, petabytes or terabyte or whatever, amount of data that you want to manage, you can do it easily in Elasticsearch. You just need to add another node, another server, and with just a simple configuration file, you can connect together. So it's very, very simple to scale. It's very fast. I would say this is one of the killing feature, not the only one, but for sure the most interesting, because it performs near real-time search. So basically, under the hood, the Elasticsearch uses Lucene, that is an Apache project, in order to manage, to perform the search engine, actually. And this is offered, this feature that is very, helpful for, for any search application. As I said, there are a lot of features. I will try to give you some, introduction to some of them. The more important are the filtering. So you can perform with Elasticsearch, you can filter your data, you can aggregate your data, you can analyze your data if you need to do some statistical or data mining or data science, activities. It's technically speaking is a database document oriented using JSON as documents. And when you perform, when you store an object, a document into a database, this is called actually an index. So an index is actually a collection of documents, and you can think about index as an equivalent of table in SQL. In order to interact with Elasticsearch offers a REST API. So there is no client or shell tools. You can just perform an HTTP call with the API, and you can perform all the operations. So everything is REST API. This is also very interesting. So for instance, imagine that you are using Cur. It's very popular, HTTP client. So if you perform this command, so just a get in the root of the Elasticsearch, that by default the port is 9200, you will get back a JSON response. In this case, as I said, this is just a get on the root. That is an info endpoints. So as you can see, we have some kind of information about I don't know, the version number of Elasticsearch that is running, even the Lucene version, because as I mentioned, Elasticsearch use under the hood Lucene to perform the search. Query, and this is the version of Lucene used in this version. And by the way, this is the last stable version 7. Actually, no, this is not the last. We get 7.13.1. How you can install and run Elasticsearch? As I mentioned, Elasticsearch is free and open software. So the easy way actually is you can download it if you want and run by yourself. But we provide a nice Docker image on docker.elastic.co. So if you go here, you can download it. For instance, if you want to run, if you want to pull the latest version that actually is 7.31, this is the command to get the image. And if you want to start only a single node cluster, for instance, just to try, as I said, by default, the port is 9200. You can just run opening this port and specifying the discovery type single node. That's it. So after that, you can start consuming Elasticsearch running on a localhost on 9200 port. Okay, let's jump. As I said, this was a very, very brief introduction to Elasticsearch. Now let's focus on PHP. So we are PHP developers. We want to use Elasticsearch, how we can use it. So we provide an official PHP client that is elasticsearch-php. So you can check it out on GitHub. It's updated and released with all the stack version of Elastic. So every time we release a new version of Elasticsearch, in this case, we provide a new version of the client. It uses a connection pool inside the Elasticsearch PHP. That means you can manage a set of nodes, a cluster of nodes about Elasticsearch, and exposes basically all the API. So all the API that Elasticsearch offers are exposed into a client class of Elasticsearch PHP. So basically each API is mapped as a function in this client class, and each function returns the body of the HTTP response from Elasticsearch. The body is a JSON, as I mentioned. So by default, we deserialize the JSON into an associative array. So basically the return of the function is an associative array. This is for the not regular, I would say, API. For the API that returns without a body, actually, with the head, for instance, head methods API, the function returns a Boolean value, so true or false. So just to give you an idea, as I mentioned, the body is deserialized from JSON. By default, we use an associative array, but we exposes a serializer interface. So if you want, you can create your custom implementation of the serialization and inject this implementation into Elasticsearch PHP, and this will modify the return of the function call, basically. In case of errors, for instance, 4 or 5, 400 or 500 status code of the HTTP response, we throw an exception that is an extension that extends the Elasticsearch exception interface. For instance, if you get a 404 file not found, for instance, you are getting some information from an index that does not exist, the Elasticsearch PHP will throw an exception, and this exception is missing 404 exception that implements the Elasticsearch interface exception. All the endpoints are generated automatically. So that means we have a specification on the Elasticsearch project. Is a REST API specification in a custom format using YAML. If you're curious, I will provide the slides, and when you see here, the underscore, these are basically the hyperlink, so you can click and have a look when you will have the slide. So basically, we provide all the specification of the API. We separated in open source and XPack. There are two versions of Elasticsearch. But let's say we basically, for each version of Elasticsearch, we provide the update of all the APIs. So you just need to update using Composer the library, and you will get the new API. The client is tested, of course, using normal unit test, integration test, but also using the YAML test that are the same test that the Elasticsearch projects use to test the integration test of Elasticsearch, basically. Elasticsearch is a Java project, and they use this. They have this set of YAML tests. In Elasticsearch PHP, we are reusing the same suite of tests, this YAML test, and we perform. Basically, we check that the API that we call, the function that we call in the client of Elasticsearch PHP, returns the expected value using this constraint of the YAML test. So let's say we test a lot the client. Just a slide to give you an information about the popularity of this project, Elasticsearch PHP. We recently hit 50 million of installation. These are statistics on packages. So it's, I would say, quite popular. As I said, all the code is auto-generated from the API specification of Elasticsearch. And of course, we try to map to give all the possible information about the API. So just to give you an idea, if the API is index, for instance, this is the put methods and the URL that you have to provide to perform this API. Index means, as I said, storing information in Elasticsearch. We will create a function that is index. So we try to use the same name. And we use the $params, that is an associative array, where basically you specify all the parameters for the specific API. So very simple. We map one-on-one the name of the API with the name of the function. In case of namespace, because there are some API that are under, for instance, the cluster namespace. So we basically, as I said, provide a set of API specific for the cluster feature of Elasticsearch. We use the same approach. So basically, we create an intermediate object that is a cluster. We call it namespace. And we provide the function according to the specific end space. So in this case, it's cluster and stats to give the statistics about the cluster configuration. As I said, the API parameter is managed by an associative array. So this is just a screenshot of the source code of one specific API that is the index. As you can see, we have here the $params, that is an associative array. And as you can see in the PHP doc, I provide all the information about all the possible parameters with the code documentation. So basically, if you are using an IDE like Visual Studio Code or JetBrains and etc., you will have auto completion, and you will get also this information when you are developing. So you don't need to go to the documentation of the Elasticsearch API in order to understand the meaning of the parameters, because there are some endpoints like the search, for instance, the most used one. There are hundreds of parameters, so it's quite difficult to remember all the parameters, of course. And also, as you can see, we provide an hyperlink here using the @c, that PHP doc, for the specific documentation specific for the index itself. So, as I said, we try to get all the possible information inside the source code. So if you are using autocompletion, you will get some, tool to help your day-by-day usage. How to install the library? Of course, using Composer. This is the name is Elasticsearch/Elasticsearch, or you can add in Composer JSON as usual the requirements. How to connect to Elasticsearch, for instance, and calling the info API. This is basically the same example that I give you using the curl command in the previous slide. So basically, you have to create an instance of the client. In order to do that, we provide a client builder. A client builder is a factory, basically, to create the instance of the client, specifying the parameters. So you need to, call the create function, the set host to specify the host, and as you can see here, there is the S for the plural, because you can specify a cluster of nodes. In this case, it's just one node, but you can see here that you have to specify this using an array. So this is basically the address, the URL of the node, and you at the end you can perform the build. So basically, the $client will be an Elasticsearch/client class. In order to perform the info, you can just execute the function info that will not require any parameters, and you have the results back. So if you were dumped the $results, as you can see, this is an associative array that maps the JSON of the body response. And for instance, if you want to check the version number of Elasticsearch, there is this version number key. So very, very, very simple. Imagine that we want to connect to a cluster of nodes, not just one single node, but a cluster, so a set of nodes, and call the cluster health API. You can specify the list, as I mentioned earlier, in the set host, the list of all your nodes, and you can perform a cluster health to give information about the health of the cluster. For instance, to understand if some node is up or down, the status of the cluster, basically. And you will get back this information. For instance, I just highlighting the number of nodes in this associative array, and you can have active perform shard, number of data nodes, and etc. These are all information about the specific node, because in Elasticsearch you can have specific nodes for each version: the master node, the data node, the replica node, etc. As I mentioned, Elasticsearch is a distributed engine. So in the client, you need to perform a connection pool, basically, because imagine that you have 3 instances of Elasticsearch running, so Elasticsearch 1, 2, and 3, and you have the PHP client, the software that wants to spread the traffic according to all the 3 nodes, basically. So inside the Elasticsearch PHP, we perform a connection pool. So basically, the first time we call the first node, the second time the second node, the third time the third node, the fourth time the first node. So there is basically a round-robin algorithm going on that try to spread the traffic between all the nodes. Of course, if a node is down, for instance, imagine that the first node is down, the connection pool is automatically updated, and we basically skip the node 1 when we are the PHP client continue to use only the cluster only with the node 2 and 3. So there is this logic inside the connection pool. We also provide a resurrect algorithm. So we try after some time to ping the first node, and if it's on again, if it's up again, we add in the connection pool. So it's dynamically, but this really depends on how you run your PHP client, because if the PHP client is just a normal web application, make not a lot of sense to give all this logic for the connection pool, because you execute the PHP code and you perform, I don't know, 3, 4, 1 endpoints for each execution. So make no sense to to manage. But if you're, for instance, running an asynchronous application in PHP, like a daemon, using, I don't know, React PHP's wall or whatever, so something that stays in memory, in this case, the connection pool is important because you have to resurrect the nodes. Otherwise, you will basically, if a node is down, they will not accessible anymore. So it's important according to the specific use case, of course. As I mentioned, everything is managed by interface. So for instance, for the algorithm, for the connection pool, we provide a selector interface that you can customize, basically the algorithm that you want to use in order to pick up the nodes, the selection of the node. We provide some default implementation like a round robin, that is the default algorithm. We offer also the sticky round robin, that is actually a round robin, but use a current connection unless it's dead. Otherwise, use round robin. So it's just a simple, a change in the round robin implementation. We provide also a random algorithm that's select a node randomly, and as I say, you can implement your logic, your custom logic, implementing this selector interface, and you can actually specify when you build the client in the client builder with set selector the specific implementation that you want to use. As Elastic, we provide also cloud infrastructure. So if you don't want to run by yourself Elasticsearch, you can just create an instance on Elastic Cloud. And of course, you can use the PHP client to connect to the Elastic Cloud. We provide two kinds of authentication. One is basic authentication using username and password. You have to specify a cloud ID, that is specific ID that Elastic Cloud platform will generate for you when you register it. Or you can use an API key, that is more likely the case because it's more secure in some way. Basically, you have the same Elastic Cloud ID, but you specify an API key. So this API key you can generate by the backend, the admin interface of Elastic Cloud. So you can have different API key also for different applications. That's why I said it is more secure. Okay. Everything is managed by JSON because Elasticsearch uses JSON by default as data storage, data format, sorry. In PHP, JSON is supported, as you know, using the JSON encode and JSON decode function. And starting from PHP 7.3, there is also the JSON exception. So you can specify using the constant JSON throw on error. So you have to pass a flag, basically, that generate the JSON exception. And of course, we use this approach in Elasticsearch PHP. So when we have some, JSON that is not valid for any reason, we manage this using the JSON exception provided by the PHP itself. Talking about JSON, there is I would say one thing to know about the empty object, because an empty object in JSON is just it's just an empty object using this format here. In PHP, in order to create an empty object, you need to create a new standard class, for instance. So an empty object in PHP, as you know, there is the standard class that is, as the name said, the standard class of PHP. Basically, you can create an empty object using this custom that is present inside the language itself. So basically, long story short, if you have a JSON like this, where, for instance, highlight fields content is an empty JSON object, and you need to map using an associative array in PHP, you need to do like this. So basically, this is the body, as you can see. The map of the JSON is very simple in PHP using associative array, but for the empty object, you need to remember to use this syntax. So you have to create a new empty object. You can even specify different, class with an empty class, whatever. But I suggest to use the standard class of PHP. Okay. Talking about the data management API, so the basic operation like index, update, delete, and etc. So if you want to add a document, you have to perform this index operation using the name of Elasticsearch. And this is actually very simple. You need to create a client, as I showed earlier. You have to specify the parameter. So you have to specify the index name. So you have this key index. You have to specify the name of your index, the ID, because an index is a collection of documents. So it's a collection of JSON. The ID is the specific document, basically. And you can pass your ID if you have it. If you don't have an ID, you can even skip this ID, and Elasticsearch will automatically create an ID for you. And in the body key, you can specify actually the body, the document itself, using associative array, as I said. So this is basically a JSON with one property that is test field, and the value is ABC. And you can perform the index API just calling the index function, passing the $params. If we were dump the results, basically we'll have some information back. The underscore ID is basically the ID that we provided. In case you didn't pass, this will be a random ID generated by Elasticsearch. And if you want to check the results, so if the operation was successful or not, you can check for the result key that is, in this case, created. So that means everything was okay. Of course, the HTTP response is 200 in case of success, but this is the result specific. So this is 200, but the results inside the engine itself. So if you need to perform, imagine that you want to index a set of documents. So instead of iterating and using index, so I don't know, you have 100 documents, you want to index this set in Elasticsearch. You don't want to perform 100 HTTP put API call in Elasticsearch. So you can use a bulk API. So a bulk API is basically an index. Basically, you can perform an index, create a delete or update action using a set of documents in a single request. So this, technically speaking, this uses ND-JSON. So it's basically JSON where each line is basically a set of JSON where JSON is specified in each line. And in PHP, you can just perform a bulk API creating a body. So the same body params that we showed earlier, but as you can see here, we are using an array. So basically, we are creating 100 documents in one single API call. So the first line is basically the name of the index that you want to use in this case. And the second line is the content of the body. So this is a loop. So basically, for each document, we will have two lines. The first is the index name, and the second is the body, the content body. So when you have this $params, you can just perform the bulk operation. So again, this will perform just one single HTTP call, storing 100 documents in one HTTP call. So this is very convenient if you need to store multiple documents. As I said, we generate some exception if something is wrong. For instance, imagine that you are trying to retrieve a document, so specifying an ID that does not exist in Elasticsearch, you will get back a 404 exception, specifically a missing 404 exception. And this is just an example. So imagine that you want to get this document, this index, and this ID, but the ID is not present in Elasticsearch. So if you try catch the get, that is the API for getting back the document, you can catch the missing 404 exception. In this case, clearly means that the index, the ID is not, the document is not present in Elasticsearch. So very, very simple to manage this kind of error. You know, the main feature of Elasticsearch is searching. So the API for searching is quite big in the sense that provide a lot of feature. All the parameter are specified by the $params. So in this case, the documentation helps a lot. But imagine that you want to perform a very basic operation, a very basic search using just a match for a term. Imagine that you have a document stored in Elasticsearch that contains a test field. So this is the name of the field that you want to search, and you want to match all the document that contains a test field with the value ABC. So this is match 101, not very interesting, but just to give you an idea. So if you perform this search, you will get back an associative array where basically the results are stored in a hits key. So as you can see, there is on the root this hits that contains the total value of the document find and the maximum score. So this is interesting because each time you will get back a response from Elasticsearch, Elasticsearch will try to give a score about the documents. So high number means that the score is more related to the search query. So if you have, for instance, in this case 0.28, that is the maximum score. This is not so relevant, information that Elasticsearch find using this query match. But if you have, for instance, 0.05, 0.6, that means that the results, the document is very close to the query that you provided, because of course Elasticsearch provides a lot of feature also to find document that does not one-on-one match. Otherwise, it's like to use a relational database with a simple select. Elasticsearch provides you a very advanced features, for instance, to run the fuzzy search. So even if the term that you are finding is not exactly the same of the query, Elasticsearch will try to match and give you some scoring with using a scoring algorithm, the results itself. So it's very convenient if you have to, for instance, search, if you have to implement a search feature in a web application and you want to provide if the people do some mismatch or some terms that are not the same of the document stored in Elasticsearch, you can create a very nice search experience using this feature. Okay, so as I say, the results is under the it's. So here we have basically the documents of the results of the search. If you don't want to use associative array, you can even use a JSON string to perform the search. For instance, imagine that you are, I don't know, moving from one application to another, or you're copying and pasting some example in the Elasticsearch documentation in some forum, and you want to try, some JSON HTTP call with the JSON as a string. You can even, as you can see here, specify a string of the JSON. So this is just a string that specifies the JSON. And in the body, you can just specify the $JSON, the value. So you don't have to map using associative array. You can even inject the JSON if you already have it. So this can be convenient. Imagine that you have a lot of results. For instance, maximum 10,000 hits as results. And of course, the search is limited to it uses pagination in order to give back the information. So in order to use this pagination, you have to use basically the scrolling feature of Elasticsearch. The scrolling feature basically it's very simple in the sense that you just ask for scrolling when you want to search, and the Elasticsearch will provide you back a scroll ID, so an information that you need to pass again in the second request in order to continue the execution on the next page, basically. So very, very simple. One thing to understand about the scrolling, that this is, it's provide you a point-in-time snapshot. That means when you execute the first query, you will get the results. The results are basically Elasticsearch will provide a cache of these results, a snapshot of these results. So the second time you will read the second page, Elasticsearch will provide the same information that was generated in the previous call. This is important because if you have an application that is performing a lot of update, a lot of change in the data itself, and you are scrolling information, you can have back different pages because each time the data can be changed. So that's why we introduced a point in time snapshot. So again, the first time you execute the search and the scrolling, Elasticsearch will provide a snapshot of the results and will give you this snapshot each time you iterate on the pages. So you don't have inconsistent data basically back. That's why. How we can perform this operation? As I said, very simple. In the parameters, you have to specify the scroll. In this case, I'm just using 30 seconds. So this is the time where the snapshot will be available for the searching, basically. You can, of course, change this number up to, if I remember right, 24 hours. The size of the results. So this is the size of basically the pagination. So 50 hits per page. This is the index, and this is the body, the query. So match all means select star in SQL terminology. So how to perform the pagination? You perform the first stage. You can do a while, basically where the hits are still present, because the hits, the count of this array gives you the number of results. So if it's more than 0, that means we can iterate on the next page. And you have just to perform a scroll API. So the first is a search, and the other are just a scroll function, where you pass basically the scroll ID, that is the previous $result scroll _ scroll ID. So this is just a field that is the results from Elasticsearch. You just need to read it and pass it again in the scroll to perform the pagination, basically. Very simple. I already mentioned about the fuzzy search. In Elasticsearch, we use the Levenstein edit distance. What is the edit distance? Is the number of one character change needed to turn one term into another. For instance, imagine that you have the string box, and in Elasticsearch, a user just search for fox. Elasticsearch is able to understand, okay, the difference between fox and box is just one character, the first one, the B and the F. So Elasticsearch will give also in the fuzzy search this as results, because maybe the user, mistype the name. If you remove a character, the same. So the distance, the Levenstein distance is the same. It's just one. Because, for instance, if you have black and lack, so if you remove the B, the distance is 1, and Elasticsearch will give you back the information. If you insert a new character like sick and sick, the K at the end, this is one edit distance. And if you transpose two adjacent characters like hacked and cacked, so A and C, if you change it, even here, this is one edit distance, so Elasticsearch will give you the information back. Just to give you an example how to perform this, it's always a search, as you can see, everything is performed inside the query. You have to specify the fuzzy, so using this key, and the name actually that you want to search, the index name, the field name that you want to apply the fuzzy search, and the value. In this case, the value is Harry, the string Harry. So imagine that you have 3 documents in Elasticsearch, where the first has a string, I will marry you because I love you. The second, I will live with Harry. And the third, I'm sorry for your loss. And you perform this search using Harry. So in the first case, if you analyze the string, there is a Mary that is one edit distance from the Harry, because the M and the H, you just change one character, so it's 1. The second document I will leave with Harry, and Harry is the same string, so the leaving distance is actually 0, so it will add it in the results. And the last document, the minimum leaving distance is 2 because there is sorry, and you have to actually change 2 characters, the S and the O, the first 2, in order to have array. So is the edit distance is 2, and this will not be present in the results. Of course, the array, so the second document, will have a score higher than the first one because the distance is 0, so it's the same. So this is just, again, an example, very simple to try to understand how the fuzzy search work in Elasticsearch. As I mentioned, there are a lot of other features in Elasticsearch, for instance, aggregation, very briefly. Imagine that you want to aggregate your data to provide some metrics, statistics, or other analytics. For instance, you want to know, imagine that you are storing information about the log of a website, for instance, Apache log or Nginx log, and you want to know about the average load time. This is very likely aggregation query. If you have, for instance, an e-commerce application and you want to know the most valuable customer based on transaction volume, this is another aggregation query. If you want to consider a large file on a network, again, logging some network information. So this kind of, for instance, how many products are in each product category. So imagine that you have category, you want to aggregate by category. You can perform this aggregation. Just briefly example, to perform an aggregation, again, we are always talking about the search function. You need to pass the AGS key, the name of the aggregation that you want to create, actually, because this is a new, basically, property, a new field of the results, and you have to specify which field you want to aggregate. Imagine that this is a stock market documents, so an index that you have a store of all the stock, value of the stock options. And you can actually create, you can aggregate using by the same stock name. So I don't know, if you're interested in one stock name, you want to have aggregate all the results specified by the name of the stock, you can just specify the field stock here. And basically, if you perform the aggregation, as you can see in the results, there will be another field that is aggregation with the name of the aggregation that you gave here, my hug name in this case. And inside this, there is a buckets field that contains the results, so the aggregation results. Another cool feature of Elasticsearch is the highlighting. So imagine that you want to search for some term and you want to give back to the user the document highlighting the term that the user found. So very familiar, feature in many, search engine. Imagine you have this search application, you write MPH here, and these are the document that contains this, keyword, and you want to highlight the term inside the document. This is done by default in Elasticsearch. You need just to provide an highlight in the query. So imagine that you have a simple query with match the stock option, the example previously with the AAL, that should be American Airlines or something like this. So you want to aggregate this, and you want to basically have the information back using the highlight. You just need to specify the highlight, and actually the name here, this name here is the name of the fields using an empty object. And here, as I mentioned in PHP, in order to create an empty object in JSON, you integrate an empty standard class object. So you can perform a search. Basically, here we are just performing the search, and we are iterating inside the its hits that are the results. And there is a specific highlight key in the results where you have basically all the documents with the specific term highlighted by default using EM tags of HTML. You can change it if you want. So for instance, this is typical results of this code. you have an array of values where each array is a document itself. And as you can see, inside the document, there is already the highlighting. So with using the tag hem of HTML. So you can easily use this string and with a specific CSS talking about a web application. You can change, of course, the ehem key. This is so by default, this is assuming you're building a web application, but if you're building different and you have a different syntax for highlighting, you can change it in Elasticsearch. Last feature that I want to present very briefly is Schema Read. This is a feature that we introduced recently in the 7.12 version of Elasticsearch. And basically, this introduced the ability to create fields at runtime. So imagine that you have a document that contains some fields, and you want to provide, a search and adding some fields using a script language. So this is interesting because open a new possible use cases. For instance, if you want to adapt a changing log format or fix an index mapping, you don't have to knowledge about the data itself. So you can just put in Elasticsearch and try to, perform this schema read to extract information back. So you don't need to map. You don't need to understand the data before you search it. So it's very interesting feature. So imagine in the stock option example that you have the high and the low price for a stock, and you want to create a new field that is the average. So the average of the high and the low stock options. You can easily do that using a search itself, using this schema read feature. So as you can see in the body here, we are specifying a runtime mappings, where basically we are creating a new field that is average. The type is double because it's average. And this is the script. As you can see here, we provide the script using this syntax. Inside here, you can understand that this doc high value. So basically, this is the value of the high field in the in Elasticsearch. So we are reading these two value, high and low. We are performing a mathematical operation, and we are creating a new field that is the average fields. So this can be interesting. Okay. In Elasticsearch PHP, you can even perform asynchronous operation. So you can call asynchronous endpoints. This is called future in the terminology of Elasticsearch PHP, and this is provided by the libcurl implementation, because PHP is fundamentally a single thread, but there are some libraries like libcurl to perform HTTP connection that provide parallel way, an asynchronous way to execute HTTP call. How to do that? Very simple. In the $params, you have to specify a client key with the future lazy. So this is the way that you basically say, okay, I want to perform an asynchronous operation. So each time you will perform, this is a simple get operation. Basically, this HTTP call will be performed asynchronously. So that means the PHP code will not block the execution here in $future, but you can actually, the PHP will continue the execution. When you introspect, when you read in the $future, basically this is a blocking operation, because if the HTTP call is not finished, of course, PHP needs to wait for getting back the underscore source field. So only when you are reading the information, this is a blocking. We provide also a wait, because imagine that you want to perform, 1,000 operation, 1,000 of get asynchronously, and you don't want to block. So you can perform this, for instance, loop here, performing the get. This is, again, with the future lazy. And you can actually wait that force the future resolution and will execute the underline curl batch. So this is another. If you're interested, I suggest to have a look at the documentation on the future mode of Elasticsearch PHP. Okay, I almost finished. I want just to give you 2 minutes talking about the future of the client, because we are working to refactor basically the client using PSR standard, because right now we just use PSR 3 standard for logging. We want to use PSR 7, 17, and 18 for leveraging the PSR standard for HTTP message, HTTP factory, and HTTP clients. We will use, let's say, any PSR 18 HTTP client. By default, we use Gazelle, but if you want to use another HTTP client, you can just specify when you create the client builder. And of course, we will continue to offer asynchronous operation. If you want to have a look at what this look like, this is actually work for Elasticsearch PHP 8. So when there will be Elasticsearch version 8, so the next major version, because we don't want to break, of course, existing code. You can have a look at this project, Elastic Transport PHP, that basically is an abstraction of an HTTP client for all the Elastic products, talking about, of course, PHP. Okay, so I finished. Thank you very much for your attention.
Thank you, Enrico, for the talk. Very interesting. And you got quite a few questions, so let's try to handle them. We should have enough time.
Okay.
The first one is if you do use any general available tools to generate the PHP library from the Elasticsearch API from Lorna.
No, at the moment I'm using the existing PHP client is using the default, a custom, I would say, implementation. So I'm just using a template for template file for the class. For the future, I'm going to use a tool that actually I'm not finding at this moment. I don't remember the name of the library, but there is a very nice library in PHP that generate the code for you. So if you give me some minutes.
Yeah, don't worry. We can try to see. Okay, in the meantime, we can skip to the next one, which is, do you also have plug-and-play components for frameworks like Laravel Symfony? I think maybe there's a bundle, but I don't know if it's maintained by you.
It's not maintained by us. There are a lot of open source communities project around Elasticsearch that use Elasticsearch PHP itself to offer, bundle for specific framework or even helpers or high-level client. There is Elastica. This is a very nice community project that use Elasticsearch PHP under the hood to give a object-oriented interface, because as you saw in the presentation, everything is very low level, I would say, because you have this associative array, you just pass this information to a function and you give back another associative array. So it's very one-on-one to the API. If you want more abstraction, you can use this community layer. I didn't mention that my goal is to offer also an object-oriented interface for version 8. So I want to support the existing interface using array access. There is an interface in PHP that is called array access. So if you implement this interface, you can just basically read the object as an array, as an associative array, as we are doing at the moment. But in the future, I would like to also offer our results as an object, so people can search, you will get the response of the document. You can iterate using an object-oriented way.
Yeah.
So more convenient.
In fact, that was the next question. Why okay. Or if you are planning to use objects instead of arrays. So in your case, you're basically doing both of them. Probably, yes. I think you will do it for cross-compatibility.
Yes, exactly. I did this for not complain about the user, because we have a lot of users and I don't want to spend my time, GitHub issue.
So you're basically giving to both of the preferences a way to work. So yeah, everybody wins this way. Yeah. Okay, next one is, let me see, compared to all clients on Elastic in other languages, how is PHP client's performance?
I would say the same, in the sense that the implementation of other clients is very similar. So we are a team of the clients team inside Elasticsearch. So in my daily job, I speak with .NET, the author of Elasticsearch for .NET, Python. We have a lot of Node.js, Ruby, Java. So the implementation, the algorithm, the idea are shared against all the team. Of course, there is difference for the language itself. For instance, Go, that is quite fast. If you compare, the indexing of Go and PHP, of course, there is some difference, but not because the difference of the implementation, but for the language itself.
For the platform,
but I can say that we have some benchmark with asynchronous call where PHP is quite fast.
I know that
you did
many benchmarks in the past also about PHP version in the clean. So you do care about this stuff.
Yes.
They're also asking if you are planning to offer other ways to access apart from REST API like gRPC.
For the moment, there is no plan for this, but never say never.
Never say never to the future, right? Let's see if we can squeeze a couple more questions. When would you recommend Solr and when Elasticsearch? Could you mention the most important differences or use cases?
This is a very big question. Of course, I'm a part of Elastic, so I have bias here in the response itself. I will say Elasticsearch is more simple to use and gives you also a lot of additional features that are not implemented in Solr by design. So that's what I can say in 1 minute.
Yeah, no, sure, I understand. In fact, next question asks for another comparison with Elasticsearch, but I don't know that. Yeah, I think it's a SaaS for search.
It's a SaaS, but to be honest, I have no technical details about it, so I don't want to.
Okay, let's go over because we have really at least another 3 questions.
Okay,
can runtime mappings schema on read be used with aggregation query? For example, create the average field you showcased, but use that field as an aggregation field for the query.
Yes, you can do that. Something that maybe I didn't mention, schema on read is very helpful, but it's more for designing aspect, for testing. Is not really for production in the sense that it's quite slow if you compare schema on read and schema on write. So the main difference is schema on write. Of course, everything is done when you write information inside Elasticsearch, so the read is very fast. Schema on read, as the sentence say, the schema is built when you read the information, so it's on the fly. So if you compare the performance, of course, are not comparable. But again, this is nice tool for testing, experimenting. I envision this usage more for again, you have unstructured data. You want to perform some operation. You don't have to map and reindex every time. You can just build this schema on read and understand how the data are structured. When you understand it, I suggest to use the schema on write for production. That's
so basically you're iterating over your data and trying to understand and explore it on the fly until you find something of meaningful, right?
Yeah, or if you have a legacy application where you cannot reindex stuff because you already have this can be very helpful for this kind of.
So you have another constraint, basically.
Yeah.
Okay, another one. In a context where data changes many times by the user, what should the approach be? Could we use an RDBMS, or a relational database, to store the data and sync them periodically to Elasticsearch, or there is a better way to do it?
This literally depends on the use cases, on the, even which kind of data you're storing. Most people store the data, important data, in a relational database, and in parallel in Elasticsearch to perform, search near real-time search operation. So you can perform both. You store the data because you want to be sure that the data are stored in a robust environment, in an ACID environment, and you do the same in Elasticsearch for searching operation. So this is quite popular. But I see also some application where the data are petabyte by day, where you cannot do this. So the only way to do is using Elasticsearch.
Okay, clear, pretty clear. Thank you, Enrico. I think we have to cut short since we are nearing the timeline for the next talk. Thank you again, and see you, let's hope, in person next year.
I hope so. Bye-bye.